What is meant by oscillator, guys? Okay, so this circuit which generates the clock signal required by the microcontroller. The clock ensures the operation inside the microcontroller perform the synchronized manner. So what it actually means there is, so we already discussed it. If you take any microcontroller, okay, before going to be show the uh, thing, I'm going to be show the oscillator. Okay, so STM32 board. Okay, I'm just open up the STM32 microcontroller. Here, if you just check this one, so this is the oscillator. Okay, so this is the oscillator, and for yeah, I'm just open up the Arduino, guys. So this is the oscillator. Okay, so this is one of the microcontroller. So this is one of the microcontroller name. It is called as an STM32 microcontroller, which is ARM-based microcontroller. Here I have been opened the basic Arduino microcontroller, which is also having the same. Your oscillator is there. Okay. So if you open up, if you just search any microcontroller, even you just search 8051 microcontroller, that is also having a crystal oscillator. So if you just take any of the microcontroller, definitely which is having the crystal oscillator. So that is going to be looks like this. Okay, what is the purpose of this crystal oscillator and why this crystal oscillator which is presenting in every microcontroller? So that is what we are going to be discussed in this today's live. Okay, so we know that this crystal oscillator is representing in every microcontroller. Right, because it is mandatorily going to be working. It is what is the purpose of this? We are going to be discussing. So here, the name itself, it is telling the thing. It generating the clock signals. What is the purpose of this one is? It generating the clock signals. Okay, so this crystal oscillator, which is generating the clock signal like this. Okay. Okay, I hope you got this one. So inside the microcontroller, execute the a synchronized processor. Okay, so previously we discussed it, guys. So you just consider this is your processor. This processor can do the processing the instruction. Okay, what is meant by instruction means if you just write like you in your program, even if you write a program in any IDE, whatever it is, just written like this. Like you just add the two datas of R1 and R2. R0 which is having one data, R1 which is having another data of 5 and 4. For example, you just giving a task to add R0 and R1. Okay, so this processor which is taken as an one instruction. Okay, so this is gonna be one of the instruction. Okay, so in processor, if this instruction is going to be processed, it requires the clock pulse. That means clock. Okay, so if it is having a clock only, it just process that instruction. If it is not, it is not going to be processed. Okay, so how it is mandatorily working? If you are just giving an instruction without this clock pulse, it is dead. It is not going to be do the processing the data. Okay, so the clock pulse is playing a major role in it. Okay, so now uses external clock oscillator of which is in 8051, which is using a 11.059 megahertz. Okay, just using a 11.059 megahertz frequency range up to it producing a clock pulse. Okay, so you just keep it on the mind. So what is the purpose of clock pulse, guys? Even you just given the how many number of instruction, whatever the number of instruction, for every instruction it requires the clock pulse. So how many number of clock pulse it requires, and so everything we will discuss it in this live. So you just keep it on the mind. For one instruction, if you want to be processed, definitely you requires the clock pulse. So the processor requires the clock pulse. And what about the frequency rates? 11.059 megahertz up to it will be produced in this crystal oscillator. Okay, here, if we just check it here, this is very, very important thing. Okay, So the mission cycle frequency, one mission cycle is equals to 12 oscillator period. That means if you want to process one instruction, for example, this instruction you want to be processed, you require one mission cycle. What does mean by mission cycle means you're just counting how many number of clock pulses you want it. Okay, you require 12 clock pulses. How many number of clock pulses? 12 clock pulses, which is equals to one mission cycle. One mission cycle which requires to process one instruction. You got clear? You got clear, guys? So, oscillator producing clock pulse. So, if you take 12 clock pulse, that is gonna be the one mission cycle. Okay, mission cycle. So, that one mission cycle which required to process one instruction. Okay, so this is how the flow will be. So, I hope you will got up to this point, guys. Okay, if you got clear, so you just post answer on the chat box, got clear. Okay. And now we are in the crucial to understand how it is actually generating the clock pulse. Okay, we are going to be learn this one right now. How quartz crystal generating the clock signal. That means quartz crystal. Okay, what does mean by quartz crystal? So you are going to be understand this. It is having a piezoelectric. It is what is actually inside this oscillator. So that is what we are going to be understand. Got okay. So now I'm going to be tell you that what is actually inside this oscillator. Okay, so you can, if you understand those, so whenever you just seeing this oscillator, yeah, you can easily tell. So these are the things which is present inside this oscillator. Okay, so inside this oscillator, definitely one quartz will be there. That means one crystal. Quartz means it is a crystal. Okay, so not only the quartz, it is having a different type of crystal materials will be there. Okay, you will have the quartz, you will have the polymer. So kind of many crystal material which is available in this form of inside this oscillator. Okay, so what is the crystal is? This crystal, that means quartz crystal which is having a piezoelectric material. Okay, what is meant by piezoelectric material is? Piezoelectric materials which is helps to generating the electric charges response to the mechanical stress. Okay, what it is meant is it will be helps to convert the mechanical energy to the electrical energy, vice versa. That means inside this oscillator, I told you that it is having a piezoelectric material, that the crystal which is having the, it is also called as a crystal, guys. Inside this oscillator, we are having a crystal. Here, we are using a specifically quartz crystal. 8051 and using a quartz crystal. Okay. That crystal which is having effect of piezoelectric effect. What does mean by piezoelectric effect is, whenever you applied the electrical energy, it is producing some mechanical stress. Whenever you producing some mechanical stress, it producing a electrical energy, vice versa. Okay, so in this case, so this is the complete thing. So what are the crystal like? Quartz, ceramic, like lead zirconate, and so these are the kind of crystals, okay, which is available here. Okay, this is a piezoelectric material. Okay, so now we will clearly discuss this. When two electrodes has been placed in this above this material, inside the crystal is there, in above this two electrodes. So electrode means which is conducting the electricity, any metal plates kind of thing. Okay, so whatever the things which is conducting the electricity, so that is gonna be the electrodes. Okay, here if you're going to be apply the voltage, what will be happen? Initially, mechanically it will be vibrate, because previously I told you, if you applied the electrical energy producing a mechanical energy, so when the mechanical energy started, the electrical energy gonna be triggered. So this is gonna be vice versa. It is going to be happening continuously. Okay, in this case, previously what I'm going to be do is I'm applying some voltage. How can I apply my voltage? You know that definitely, even whatever microcontroller you have been taken, you will be giving some power supply. Right. So that power supply, this crystal oscillator is taken as an electrical energy. It is taken as an voltage. Okay. When that voltage is gonna be applied, it is mechanically vibrate. Inside this crystal is get vibrated. Okay. So this vibration now it causes some small alternating voltage. That is the output voltage. That is called gonna be we are going to be using. Okay, I'm going to be explain. So it vibrates the natural resonant frequency, for example, 12 megahertz. Okay, so this crystal frequency, which is having capability of 12 megahertz up to range, it can able to producing the frequency. So what it is exactly happen here it is. So when I give some electrical supply to my board, so this crystal oscillator it just taken this voltage, electrical voltage, and it is mechanically vibrate. It just mechanically gets stressed. So now it just produced some electrical voltage. That means electrical current. Okay. So this is a piezoelectric material. So when I hit this one box, so normally just consider any box is there. When I'm just hit that box in my leg, it just vibrated because it is mechanically disturbed. That box is mechanically disturbed. The output, your box is shaking. Right, it producing some shaking. So same thing, guys. When I want to disturb this, I just disturb with the help of my voltage. It was disturbed and producing some frequency. Okay, so producing some voltage. Okay, so this is the basic concept you are going to be understand it. If you clearly insane about this one, okay, so here crystal alone cannot giving the oscillation. That means it's just telling while giving some power supply, it is mechanically disturbed, giving some like voltage or current. It's not the complete clock pulse. It's not complete the oscillation. So what to do here it is, we have to do one circuit inside that. What that circuit is, you are going to be connected with inverter amplifier and capacitor. What is the purpose of inverter amplifier and capacitor? Why I'm going to be bring this one here if you ask this one. So you are going to be mandatorily do this circuit connection. So inside the crystal oscillator, you definitely have this one of or not. So definitely you are having a, so one is a inverting amplifier and then you are having a capacitor. Okay. So two component is very, very mandatory. So why it is mandatory means if you ask this question, internal vibrates going to be provide some small feedback. So you will be understand while we are going to be study this concept. Okay. So yeah. So when it started to producing some voltage, this is too weak signal. So this crystal alone which producing some frequency. That means some minimal voltage. Right? That voltage is considered as a frequency, right? So when it started to producing, this is too much of weak signal. That is too much of weak frequency because just hitting, just giving some mechanical stress, which producing some weak signal. How it is actually going to be enough for complete processor? Definitely not. So I'm going to be asking you one question, guys. Whenever I'm having a weak signal, what is the component is going to be help you to enhancing my signal? So all the people are going to be post your answer on the chat box. So I want to be make my signal as strong. What is the component going to be give the strong signal? Everyone going to be tell the answer on your chat box. So Bharat, will you give the notes? So you can able to get through the membership, guys, silver or gold membership. Yes, Vignesh. Yes, obviously. So Vignesh gave the first answer. Vishnesh. Uh, Ankesh, exactly. Babajan, yes, yes. So all the people have been posting the right answer. Mukesh, Aishwarya, and Abjit, Bhuvanesh. So superb, guys. So exactly, all the answers are right. So we are going to be using a amplifier. Exactly, all the answers are right. So in this amplifier, I'm just bring up this one amplifier called as an operational amplifier. So what is the purpose of operational amplifier? Why we are going to be choose this operational amplifier? So we'll see this on in basic electronic concept. Okay. But here I'm going to be tell you that here we are specifically using an inverting amplifier. So in this operational amplifier, if you look out this in operational amplifier, it's just having a two input pins. One is a inverting amplifier and another one is a non-inverting amplifier. What is the difference between inverting and non-inverting means? So whatever the signal you have been given into the inverting amplifier, it just converted your signal as a 180-degree phase shift. If you given the signal in this format with 0-degree phase shift, it is converted with exactly 180-degree phase shift. But non-inverting means if you give the 0-degree phase shift, exactly 0-degree phase shift only your output. So this is the difference between inverting amplifier and non-inverting amplifier in your op-amp. And another very, very important thing you're going to understand difference between the oscillator and your amplifier is your amplifier here, amplifier which requires a negative feedback. It just requires the negative feedback and it just requires the positive feedback. What does mean by negative and positive feedback? Okay. What does mean by feedback means, first of all, you just understand what does mean by feedback. Okay. Feedback means if you're just giving input. Yes, Singh. Yes, absolutely right. Due to wide input. Okay. Yes. So I'm going to be telling you that thing. Okay. So feedback means whether you're giving a input. Okay. It will be producing some output. That output you just give it again, you're trying to. So some sort of. So whatever the output that it has been producing, giving some output data, you are trying to give it as an input that is called as a feedback. Okay. But what does mean by positive feedback and what does mean by negative feedback? What does mean by negative feedback means if you have been given the input like 0-degree phase shift. Okay, this is your input signal of it has been producing a signal or anything like this voltage. But the output will be reverse. That means a 180-degree phase shift. Yes, that is the thing. Output will be used as an input. Yes, that is the thing. So 180-degree phase shift. Okay. That 180-degree amount of phase shift we are going to be given like this. That is going to be amplifier. So main thing is it has been phase shifted. In amplifier signal, it has completely phase shifted. Okay, that is act as an amplifier signal. But while you're going to be check it on the positive feedback of oscillator. So if you are given the signal of 0-degree, your output should be 0-degree. Only the 0-degree is going to be again given as a input feedback. So it shouldn't be phase shifted. So that is the two difference between the oscillator and amplifier. If you given the 0-degree, definitely 0-degree. If you given the 180-degree, it should be the 180-degree. Not going to be phase shifted. That is the two difference. Okay. In this scenario, we know that we are using operational amplifier, but purpose is oscillator. Both has been merged here. So how do I get? But my motto is I need to be used as an oscillator. But why I'm going to be bring this amplifier is I need to be enhancing my signal. I need to be strengthen my signal. For that, I'm just bringing this amplifier, but at output, I need to be have the same phase shift of signal. So here, what I'm doing is this crystal has been producing some kind of weak signal. We know that it mechanically disturbed. It producing some weak signal. That weak signal, I'm just give it as an inverting input. Okay, initially 0 degree inverting input. So you may ask this question, why Charlotte you are giving a non-inverting, you're not giving a non-inverting instead of giving inverting? Because if you are giving an inverting input, it will be producing a same phase shift, right? So why we are going to be specifically doing this process? So you may have this question on your mind. Okay, so I'm going to be explain this one again. Okay, so first of all, I'm just given the inverting I just given the data on this inverting signal of 0 degree. Okay, here it is automatically provided the 180-degree phase shift of signal. Okay, just think about it, guys. Think about it. If I just directly given this 180-degree to my feedback, definitely it is going to be not going to be accepted because it is act as an amplifier. Okay, it is going to be complete. Your oscillator is going to be completely act as an amplifier. If I just given this 180-degree phase shift. Instead, I just connect with the non-inverting amplifier. I'm not going to do that because of this 180-degree phase shifted data might be having some noise. So because of to reducing that noise, I'm going to bring up that LC circuit. That means inductor and capacitor connection. Okay, so tank. We call it as a tank. So this one which helps you to removing the noise and it producing a 180-degree phase shift of signal. So here 180-degree and here 180-degree both has been added up and finally you got the 360-degree signal. So initially you have been given 0 degree, output of the signal has been changed to 360-degree. Both are same, right? Both are 0 degree, same phase shift. This time, it is completely, you're going to be given as an feedback. It is going to be act as an oscillator. This process, you should never forget it in your lifetime. So, even if you just open up your thing, guys, like I just want to show the thing, like, yeah. So you can able to see it just having this circuit on here, like your crystal oscillator, which is producing that and two capacitor. So this is the purpose of it is producing this complete scenario, which is happening like that. Okay, don't just a simple yeah, Varmit Gupta. Some voltage means so here you just see this. Yeah, if you just, I already explained this piezoelectric concept. Piezoelectric effect means if you just give some electrical energy, the mechanical stress going to be created. When mechanical stress has been created, it automatically created electrical energy. It vice versa. It is continuously going to be happen. So here we are giving some voltage through microcontroller. Voltage has been applied. So inside the crystal has been disturbed. Mechanical stress has been created. Automatically small amount of voltage has been started to created. That voltage is not enough. It is weak signal. For that, we just using this complete amplifier plus capacitor circuit connection. It is enhancing your signal. So this is the complete flow. Yes, Vichendra, that is the purpose. So we will discuss then this complete basic electronics. We have to discuss this, guys. Okay, because in this basic electronics, we discuss about the capacitor. In the capacitor, we are having the LC, RC, RLC kind of circuit. So while we are going to discuss that, we will see this complete circuit determination. Okay. Okay, I hope you got this up to this point. So now, yes, amplified to up to this created. Okay, now you just think it, guys. The signal has been created. Okay, now I've got the amplified signal. Here, I've got the amplified signal. Okay, but this could you think about it? My microcontroller, could you able to understand the signal? Even we are using a ADC. Why? Because we are going to be using a ADC. Because my microcontroller can't able to understand this analog signal. It is only capable to know the digital 0 or 1. 0 or 1. Machine codes are completely having a 0 or 1. Okay, it just completely have the 0 or 1. Okay, so why I'm going to be using this one? So because of the microcontroller should be understand this one my language. That means zeros and ones. We're just converting here. Okay, but you just think it. This pulses when I'm going to be trying to give this pulses. Could you able to understand this one? Could you able to understand this one? No. So I need to be converted as in pulses. That means zeros or one. Right. So for this case, what I'm going to be do is here I'm going to be bring up one circuit. Okay. Here I'm going to be bring up one circuit. So where is the inverting amplifier? So which is inside the circuit, Babajan. So this inverting amplifier and all, which is going to be inside your oscillator, it is having this LC circuits and all. Okay. Okay. I hope you got clear. So only the capacitor and LC circuit which is going to be outside of this one. So sometimes you are going to be using LC, sometimes you are going to be using a two capacitor alone. Okay. So the amplifier which is actually presented inside this one. Embedded definitely having a more opportunity, guys. So at the same time, we need a lot of skills in that. Okay. So after we got this signal, yeah, this signal is not going to be understood by the microcontroller. For that, what we are going to be doing is we are just converting your sine wave of signal to the square waves. Means zeros and ones. Okay. Inside that, the sine waves is going to be converted as in zeros and ones of schematic trigger circuit. What does mean by schematic trigger circuit? So I'm going to be sure that schematic trigger circuit is called as a comparator circuit. Okay, comparator circuit. That means which is specifically designed for removing the unwanted noise and producing some digital signal. So this is how it is going to be. So whatever the signal you might be got it up finally by this operational amplifier or amplifier. So that analog, that continuous signal, so continuous voltage or current going to be converted as a complete square waveform of signal. Okay, so you can able to see this one. So just completely converting as a square pulses. Now your machine microcontroller understand 0 or 5. That means 0 or 1. If you give the 0 volt, it will be off. If you just 5 volt, it is going to be on. So that is only the microcontroller does know. So same logic, same logic. So when the pulses is going to be works like this. Okay. So complete 0 and off, low and high is the complete one clock. Okay. Going to be considered. So this is how it is actually going to be working, guys. Okay. Now I've been completely changed it to this one, and your 12 megahertz clock pulse up to it can able to produce 12 megahertz clock. And 8051 which is producing. So then clock pulse of CPU which is producing clock pulse. So you already explained 12 clock pulse which has having a one mission cycle. So this concept. Yeah, this concept. So one mission cycle which is having a 12 clock pulses to process one instruction. Okay. So this is very important thing. You must know this one. And flow, you can easily know the concept, how the oscillator which is having. So quartz crystal, which is having a piezoelectric vibration, analog signal has been produced. Inside this, we are using a capacitor plus feedback, inverter feedback. It is helps to stabilizing your signal. That means enhancing your signal. After that, it is having some analog based signal. You need to be converted as in square waves. So that square waves, which is going to be applied in your processor. So 12 processor, that means 12 pulses, which is going to be taken as a one mission cycle, which is processed to instruction execution, one instruction execution. Okay, so that's all the thing have been explained on here. So same thing going to be repeated, and you are going to be understand here. So this concept we already discussed it, guys. What are the states in it? Okay, if you're not be understand, if you're not going to be get this previously, introduction in so this while I'm going to be teach this concept, how what is mean by fetch, what is mean by decode, what is mean by execute. That I already discussed this concept on there. Give me yeah. So guys, this concept we already discussed, right? So what you are going to be learn here it is. So this is I already told you the previous day. Okay. So how many number of clock pulses which is going to be taking? So for one instruction. So totally which is having a 6 instruction. Okay. So 1 to 6 kind of instruction which is having. Okay. So this and all the instruction we already discussed it on previous day. Okay. I don't want to be tell it again. Okay. So what is mean by fetch? What is mean by decode? What is mean by execute? Okay. So you just consider as in state totally, which is for one instruction. So for one instruction, totally three process fetch, decode, and execute. Okay. So this is the state, and here we just consider as in 6 state. Okay. So what are those is here 1, 2, 3, which is for specifically for fetch. These 3 state, which is specifically for fetch, because program counter is there, we have to take it on the data bus, and finally we have process is going to be taking your data. And state 4 to state 4 to state 6, it is going to be decode and execute. Okay. So for each, what you're going to understand mainly is for each state, totally which is having a six states. So for each state, which is taking a 2 clocks. Okay. So totally 12 oscillator period. That means how you can easily understand this one is, so one instruction. I'm just erase it off it completely. Okay. Just consider one instruction. Okay. So one instruction, I told you, we're taking a 12 clock pulse. 12 clock pulse. That is gonna be one mission cycle. Okay. So this is the concept. I hope you got. So it just converting. So what is mean by instruction is the fetch, decode, and execute. So this fetch, and decode, and execute, which is having a 6 states. It is going to be separated as in 6 states. So 1, 2, 6. Okay. First 1, 2, 3 is going to be taken as a fetch, specifically for fetching the data. And 1, 2, section 4, state 4 to 6, state 6, it is going to be taken as a decode and execute. Okay. For each and every state, if you taken out the S1, state 1 is one of the one which is going to be having a program counter. Just taking a program counter address. Okay. So that which is taking a 2 clock. Okay. Up to state 6, which is taking a 2 clock. Just consider totally I'm having a 6 state. For each which is taking a 2 clock, totally 12 clock. So here 12 clock pulse, and here it is one mission cycle. So this is how it is actually happening inside that. So summary, if you want to be see that, this is the summary, guys. So this is how previously I explained it. Okay. So first of all, quartz crystal, and it is connected with capacitor plus inverter, and oscillation in converting a sine waves, and sine waves is going to be again converted as in square pulses, and that square pulses is going to be given as the processor. So that is your final thing. Okay. So I hope you clearly understand this concept, because this is going to be one-time study. Because oscillator, if you understand this, you will definitely going to be easily understood every microcontrollers. This is how it is actually going to be provided, but the frequency are only going to be changed. Here we are using a 11 point megahertz. In any of the microcontroller, if it is a speed, if it is having a high speed microcontroller, it is going to be very okay. So this is how it is going to be taking out. Guys, I hope you got clear on this today's session.